So as we discuss the various cloud computing architecture, let's try to dwell deeper into it. So there are two key architecture principles which basically applies to the cloud computing. The first one being the multi-purpose architecture, and the second one being the multi-tenancy architecture. So if you see, in the past, most of the architecture were proprietary and they are made for single purpose. So when we say the examples of such architectures were like, your accounting systems and the systems for storage of your healthcare data. So they are basically meant for single purpose and they were meant for a specific proprietary ways of working. So when we refer to the multi-purpose infrastructure, that is the key to the cloud computing. So multi-purpose infrastructure architecture is the key for the cloud computing. And as we see the example for, there can be a system on which the data can not only be stored, but it can be distributed over the internet. So these are the two main multi-purpose. So these are the two main architecture principles which can be applied. The first one being the multi-purpose architecture, and the second can be the multi-tenancy architecture. So if we talk more about the multi-purpose architecture, virtualization is one of the key factors that basically contribute to the multi-purpose architecture principle. So as we see, many different types of implementation can run on a same platform or types of the platforms in a virtual environment. So virtualization, as we say, makes it more easy to guarantee any kind of scalability for all kind of customer. So reinstalling a new dedicated virtual platform is much quicker and easier than installing or reinstalling a physical server. So multi-purpose architecture, as we say, there are a few key characteristics. It's based on your multi-tiered ways of working. It is based on virtualization. It is based on interoperability layer, and then it is based on the open standards and portability. So now we will dwell deeper into the likes of multi-tenancy architecture in the next subsequent slides. So as we see how the multi-tenancy architecture work, we will try to go deeper into it. So the multi-tenancy architecture is basically an architecture in which a single instance of a software application serves the multiple customers. So each customer, as we call them as a tenant, so these tenant can be given the ability to customize some parts of the applications, such as say UI or business rules, or they can be handling some customized application code. So if you see the overview of if you see the overview of the cloud computing architecture, we can certainly see the data center architecture, multipurpose architecture, tiered architecture, and service-oriented architecture. And all these architecture, when they combine with the likes of service model uh, of uh, of of of, um, of cloud, it can result into getting those services delivered either as a platform as a service, infrastructure as a service, or software as a service. So whenever you are trying to use these services, you consume these services through the likes of hypervisor. So hypervisor basically plays an important role in this kind of environment. So if you are referring to various architecture, it has to be either based on service-oriented architecture, tier architecture, multipurpose architecture, or data center architecture viewpoint. So now let's talk about the multipurpose architecture. So it has following key characteristics which we talked and discussed. So it is basically supporting the virtualization concept. So there has to be virtualization at the server level. You should be able to do virtualization at server level. It should be able to support the multi-tieredness. So there should be different types of tiers for database, for application, for load balancing, for UI. So there has to be different set of tiers which has to be applicable. And similarly for your interoperable layers, there has to be different views and standard. And then all these has to be based on the open standards, which can be portable for you to move across the different clouds. So these are the key characteristics of the multi-purpose architecture, which is followed when you are architecting any kind of cloud environment. So now let's talk about the server virtualization architecture, right? So when you are ensuring that virtualization is being managed, so you can use two ways of virtualization, right? The first can be virtualization as an operating system. The second can be virtualization with the host operating system. So you can deploy various virtual machines, right, on a single server. And that's how, on a single physical server, you can have various virtual machines which can be running across, and all these virtual machines can have their host operating systems to ensure that respective tenants are running in the virtual machines which they are put across. So we will see how it works out, right? So virtualization as an operating system. So in this example, in this case, you have the hardware, which is a basic fundamental layer. On top of it, you have a hypervisor. So you install a hypervisor, and this hypervisor acts as a virtual operating environment. And on this hypervisor, your application programs interact with your hypervisor through the guest operating system. So where there can be multiple application programs which can be installed on a virtual operating environment, and they interact with the hardware with the likes of hypervisor. So your application program 1, application program 2, all these things can be interacting with the hypervisor and the hardware with the guest operating system. So this is an example of virtualization as an operating system. So in this type of virtualization, hypervisor is the separating layer between the guest operating system and the hardware. In the next example, when virtualization with the host operating system, you have an additional host operating system which is installed on top of your hardware. So you have a hardware which acts as a foundation layer. So hardware is your server on which you are trying to build your infrastructure. So on the hardware, you install a host operating system, and with the host operating system, you have your virtualization layer, which has to be in form of a hypervisor, and with the likes of hypervisor, which acts as a virtual layer, you have various multiple application programs running on the guest operating system. So the fundamental difference is, in between your hardware and a hypervisor layer, there is an additional layer which is called your host operating system layer, which helps you to do the abstraction of your hardware by the likes of your host operating system. So in this type of virtualization, your host operating system is used as the as the first tier of access control. So it acts as the first tier of access control. So in the earlier one, we didn't have the host operating system. So hence your virtualization with a host operating system is different than your virtualization as a operating system.